In the night sky, a massive red star, one of the brightest and most notable celestial bodies, looms on the horizon. Positioned somewhere beyond the reach of our understanding, it holds the potential to release energy equivalent to an overwhelming number of stars combined. This celestial entity, poised for some sort of catastrophic event, could soon unleash one of the most spectacular discharges of energy observed in the universe, one that may dwarf the light of 1 billion suns. Are you prepared for the repercussions of such an event? This enormous red star, often referred to as a Goliath, sits relatively close to Earth and has been the subject of much speculation among astronomers and the public alike in recent years. It has undergone a dramatic change, causing a stir in the scientific community and sparking debates regarding its future. The most alarming possibility is that this shift could signal the onset of a supernova, a catastrophic explosion that marks the end of a star's life cycle. The star, having exhausted its nuclear fuel, would collapse under its own immense gravity, leading to a monumental explosion. The thought of such a violent event raises concerns not only for scientists but also for those of us on Earth, given the potential dangers it may pose to our planet. This particular star, easily recognized in the night sky by its brilliant red hue, is known by the name Alpha Orionis. It holds the distinction of being the largest and most luminous star in the Orion constellation. NASA's Hubble Space Telescope, alongside various other observatories, has been tracking the star's behavior, revealing that it underwent a significant mass loss event in 2019. Such an occurrence is unusual for stars of this type and has piqued the curiosity of astronomers everywhere. While the Sun regularly experiences coronal mass ejections, this unusual event in Alpha Orionis presents new questions about the life cycles of large stars and how they behave before reaching their explosive ends. As scientists continue to monitor Alpha Orionis, they remain divided on its exact distance from Earth. Some estimates suggest it could be as far as 1,200 light-years away, while others argue that it might only be around 724 light-years distant. Determining the precise location of stars like Alpha Orionis is challenging due to their vast distances and the peculiar nature of red giants. Regardless of its exact distance, this star is one of the most magnificent objects visible in our night sky, with a luminosity several times that of our Sun. But with this brightness comes a significant downside: its rapid consumption of nuclear fuel. The star is burning through its fuel at an accelerated pace, rapidly approaching the end of its life cycle. Ultimately, it will run out of fuel, causing it to collapse in on itself, possibly giving birth to a neutron star or even a black hole, depending on how the explosion unfolds. A critical question arises: could Alpha Orionis pose a threat to Earth? If a supernova were to occur within just a few light-years of our planet, the effects would be catastrophic. A supernova can release an unprecedented amount of light, potentially outshining entire galaxies. This raises an important consideration. Even if Alpha Orionis is located at a considerable distance, the aftermath of its explosion could still have profound consequences. Interestingly, the most recent supernova observed in our galaxy occurred in 1604, and humanity has yet to witness a similar event locally. However, in 1987, a significant supernova occurred in the Large Magellanic Cloud, located 169,000 light-years away. While it had considerable effects on its surrounding environment, it posed no immediate threat to Earth. Nevertheless, such events serve as a reminder of the immense scale of these cosmic explosions and the potential dangers they represent. The idea of a danger zone surrounding a supernova, particularly one that might occur relatively nearby, raises concerns about the potential risks to life on Earth. However, when placed within the context of the larger cosmic timeline, supernovae are relatively infrequent and small events when compared to the more powerful gamma bursts. These gamma bursts are immensely more destructive, with the ability to wipe out entire biospheres and bathe planets in lethal radiation. For example, gamma bursts can cause the destruction of a planet's ozone layer, leaving it vulnerable to the sun's harsh radiation, which could have long-lasting effects long after the burst itself. This potential danger has been the subject of recent studies, which have revealed new insights into the possible threats posed by stars that end their lives in such dramatic fashion. When large stars explode in a supernova, they can release an amount of brightness far greater than that of an entire galaxy. The sheer brilliance of these explosions raises the question of what would happen if Alpha Orionis were to go through such a transformation. If a supernova were to occur, it could become the second brightest object in the sky, trailing only the Sun in terms of visibility. Even though Alpha Orionis may be far from Earth, the explosion's energy would be so intense that it could potentially be visible during the day. Such a bright display would create shadows even in broad daylight, offering a spectacular, albeit terrifying, spectacle for anyone witnessing it. While the visible light from a supernova is dramatic, the true danger lies in the high-energy radiation produced alongside it. This radiation, typically in the form of X-rays and gamma rays, can have far-reaching effects. One of the most concerning is its ability to deplete the Earth's ozone layer. Without a protective ozone layer, life on Earth would be exposed to dangerous levels of ultraviolet radiation, leading to potential extinction events. The dangers don't end immediately after the explosion. Over time, the remnants of the supernova, including high-energy radiation and shock waves traveling at near-light speeds, would continue to pose a threat. As this debris travels through the solar system, it could further damage the ozone layer and shower Earth with harmful radiation, escalating the risks further. Furthermore, the long-term effects of a supernova's energy release can last for centuries, potentially causing lasting damage to the planet. Interestingly, some studies suggest that Earth may have been affected by a supernova in the past. Elevated levels of iron-60, a radioactive isotope created in supernova explosions, have been discovered in deep-sea sediments and lunar soil, suggesting that Earth has experienced the fallout from a supernova event at some point in its geological history, possibly in the last few million years. Currently, there are no supernova candidates near Earth that pose an imminent threat based on our current understanding of gamma risks. However, ongoing research continues to uncover additional threats posed by specific types of supernovae, particularly those that release long-range lethal radiation. These supernovae occur when a star nearing the end of its life is surrounded by a massive disk of material. The shock wave from the explosion interacts with this disk, creating intense X-ray radiation that can travel vast distances through space, potentially affecting planets within a 150 light-year radius. Fortunately, no such candidates have been identified within Earth's immediate vicinity, but this research has led to new insights into the concept of the habitable zone, the region of space where conditions are conducive to life. It appears that this habitable zone may be more limited than previously thought, with the outer regions of galaxies lacking the necessary star formation activity to support the development of rocky planets. On the other hand, the inner region, where stars form and die more rapidly, may present their own risks due to the frequent occurrence of supernovae. As researchers continue to study supernova remnants, they are discovering that the remnants of these explosions can give rise to new stars, creating stellar nurseries from the debris expelled during the explosion. This cyclical process illustrates the interconnected nature of the universe and how the death of one star can pave the way for the birth of new ones. Furthermore, supernovae have proven to be invaluable tools for measuring cosmic distances. Astronomers use type Ia supernovae as standard candles to determine the distances between galaxies and refine our understanding of the universe's vast scale. Supernova remnants, the debris left behind after a star's explosive end, are not only fascinating for their cosmic implications, but also for their role in the creation of new stars. These remnants, composed of the material expelled during the explosion, often serve as stellar nurseries where new stars form from the gases and dust left behind. This process shows the interconnectedness of stellar life cycles, as the death of a massive star can provide the raw materials needed for the birth of future generations of stars. This ongoing cycle of creation and destruction is what drives the evolution of galaxies and contributes to the ever-changing structure of the universe. As astronomers continue to study these supernova remnants, they have found evidence that new stars can form from the gas and dust in these regions, even years after the original explosion. These findings highlight the dynamic and continually evolving nature of the cosmos. Supernova remnants, with their complex and diverse compositions, are one of the most significant sources of heavy elements in the universe. Elements like iron, gold, silver, and uranium are formed in the extreme conditions of a supernova explosion, and these elements are then dispersed into the interstellar medium, enriching the matter that will eventually form future stars, planets, and even life itself. These heavy elements, created in supernovae, play a crucial role in the chemical evolution of the universe. They are the building blocks for planets and life as we know it. Without these elements, our solar system and indeed our existence would not be possible. Supernovae are therefore not only destructive events. They are also creators of the very elements that make up the stars and planets we observe today. Furthermore, the study of supernovae has expanded our understanding of the universe's expansion. By observing the brightness of type Ia supernovae, which occur when a white dwarf star in a binary system reaches a critical mass and explodes, astronomers can measure distances in the universe with remarkable accuracy. These standard candles provide a reliable way to gauge the scale of the cosmos and have been instrumental in our understanding of dark energy and the accelerating expansion of the universe. The ability to measure distances in the universe accurately has opened new doors in astrophysics, allowing scientists to map out the structure of the universe on a vast scale. But the potential hazards of these cosmic events cannot be overlooked. Even though the risk of a nearby supernova affecting Earth is relatively small, the long-term effects of such an explosion could be far-reaching. As previously mentioned, supernovae produce intense radiation, which could disrupt the solar system's environment. For instance, the radiation could interact with the Earth's atmosphere, depleting the ozone layer, which protects us from harmful ultraviolet radiation from the sun. Without this protective layer, life on Earth could be exposed to levels of UV radiation that would make survival difficult, if not impossible. Moreover, the shock waves from a nearby supernova could also affect the solar system structure. These shock waves would compress the interstellar medium, potentially triggering the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a nearby supernova could even disrupt the delicate balance of the solar system, causing catastrophic changes to planetary orbits and potentially even leading to the destruction of Earth. The study of supernovae and their remnants also raises fascinating questions about the future of the universe. As stars die and supernovae occur, the remnants they leave behind can eventually become black holes or neutron stars, some of the most mysterious and extreme objects in the universe. Black holes, in particular, are regions of space where gravity is so intense that not even light can escape. They are thought to be the end state for the most massive stars, and their formation is one of the most intriguing phenomena in modern astrophysics. Despite their danger, supernovae are essential for the ongoing evolution of the cosmos. The materials they release into space form the basis for future star formation and the creation of new planetary systems. As new generations of stars are born, the cycle of stellar life and death continues, driving the evolution of galaxies and contributing to the ongoing story of the universe's expansion. The concept of supernovae and their effects on the universe is not just an intellectual curiosity but a vital part of our broader understanding of cosmic evolution. While the phenomena themselves are incredibly violent, they also serve as markers in the grander process of galactic life. These cosmic events highlight the cyclical nature of stellar evolution, where stars are born, live, and die in a continuous process that shapes the makeup of the universe. The aftermath of a supernova is a significant event, not just for the star but for its surrounding environment. The explosion disperses a wide array of materials, which may eventually form new stars, planets, and even life itself. This recycling of material is crucial for the development of galaxies and other stellar systems. In fact, without supernovae, the universe would lack many of the heavier elements that are essential for the formation of planets like Earth. The production of elements such as carbon, oxygen, and nitrogen, critical for life, occurs within these explosions. One of the most fascinating aspects of supernovae is their ability to influence their cosmic neighborhood. After the explosion, the remnants, often in the form of nebulae or shockwaves, can interact with nearby gas clouds, triggering the formation of new stars. This process of stellar rebirth is observed in several nebulae across the sky, such as the famous Crab Nebula, which is the remnant of a supernova explosion observed in 1054. These stellar nurseries created from the debris of supernovae are where new stars begin to form, and over time, these stars will experience their own life cycles, continuing the process of cosmic evolution. Another important consequence of supernovae is their role in influencing the dynamics of galaxies. The shock waves produced by these explosions can have enough energy to compress gas clouds in a galaxy, leading to star formation. This phenomenon is particularly notable in active galactic nuclei, where the interplay of stellar deaths and rebirths drives the active evolution of galaxies. Over billions of years, this process of continual star formation, death, and rebirth alters the structure of galaxies and leads to their eventual growth or collapse. In addition to their role in star formation, supernovae also play an important part in our understanding of dark matter and dark energy. As scientists study the remnants of these cosmic explosions, they are uncovering clues that may help us better understand the mysterious forces that dominate the universe. For example, supernovae have been instrumental in providing insights into the expansion of the universe. By observing the brightness of distant supernovae, astronomers can determine how fast galaxies are receding from one another, offering valuable data about the rate of expansion and the influence of dark energy. The study of supernovae also holds promise for answering fundamental questions about the nature of spacetime itself. As supernovae release vast amounts of energy, they create gravitational waves that ripple through the fabric of spacetime. These waves, though incredibly weak by the time they reach Earth, could one day be detected by advanced space-based observatories, providing further insights into the nature of gravity and the structure of the universe. Another exciting possibility in the study of supernovae is the search for extraterrestrial life. Some researchers hypothesize that supernova explosions, particularly those that occur within close proximity to planets, may influence the conditions necessary for life to develop. For example, the intense radiation from a supernova could potentially trigger chemical reactions that could lead to the formation of amino acids, the building blocks of life. While this idea is still speculative, it adds another layer of intrigue to the study of these cosmic events. As we explore these topics, it's clear that supernovae are not just destructive forces. They are also instrumental in the creation of the universe as we know it. They are the birthplace of new stars and planets, the creators of heavy elements, and the key to unlocking many of the mysteries of the cosmos. While the immediate dangers posed by a nearby supernova may be low, the broader impacts of these events will continue to shape the universe for billions of years to come. Looking forward, the study of supernovae will likely continue to evolve with the advent of new technologies and observational tools. As our ability to detect and analyze these powerful events improves, we will gain an even deeper understanding of the forces that govern the cosmos. This knowledge will not only help us unravel the mysteries of the universe, but also further our understanding of our place within it. Ultimately, supernovae serve as a reminder of the ever-changing, ever-expanding nature of the cosmos, a reminder that the universe is both a place of immense violence and breathtaking beauty.